Hello everyone, myself Netra, studying in Sri Venkateswara College of Engineering, Bangalore. Today, let us discuss about vector table in microcontrollers. First, let us go to introduction. Introduction to vector table in microcontrollers. The vector table is a crucial component in microcontrollers that contain the addresses of interrupt service routines. It enables the microcontroller to efficiently handle interrupts by directing the program flow to the appropriate interrupt handler. The vector table is typically located at the beginning of the microcontroller's memory space. Next, purpose of vector table. The main purpose of vector table is to provide a centralized location for storing and managing interrupt vectors. Each vector in the table corresponds to a specific interrupt source or event that can trigger an interrupt. When an interrupt occurs, the microcontroller refers the vector table to determine the appropriate handler to execute. Next, structure of a vector table. A typical vector table is an array of function pointers with each element pointing to the address of the corresponding interrupt service routine. The vector table is usually located at the fixed memory address defined by the microcontroller's architecture. The size and the layout of the vector table may vary depending on the specific microcontroller. Next, initializing the vector table. During the microcontroller's initialization process, the vector table must be properly initialized with the addresses of interrupt service routines. This initialization is typically done in the microcontroller's startup code or through configuration registers. Incorrect initialization of a vector table can lead to unpredictable behavior and malfunctioning of the interrupt system. Next, handling interrupts with vector table. When an interrupt occurs, the microcontroller looks up the corresponding vector in the vector table to find the address of interrupt handler. The microcontroller then branches to the interrupt handler's address to execute the necessary code to handle the interrupt. Once the interrupt handler completes its execution, the microcontroller returns to the main program flow. Next, vector table and priority levels. Some microcontrollers support prioritizing interrupts based on their urgency or importance. In such cases, the vector table may include multiple entries for the same interrupt source, each corresponding to a different priority level. The microcontroller can then select the appropriate interrupt handler based on the priority of the interrupt. Exception handling with vector table. In addition to interrupts, the vector table may also include entries for exceptions such as reset, fault, and system calls. Exceptions are non-maskable events that require immediate attention from the microcontrollers. By including exception handlers in the vector table, the microcontroller can efficiently handle exceptional conditions. Next, updating the vector table. In some microcontrollers, it is possible to dynamically update the vector table at runtime. This feature allows for flexibility in managing interrupt handlers and responding to changed system requirements. Care must be taken when updating the vector table to ensure the integrity of the interrupt handling mechanism. Next, vector table and real-time sorry. A vector table and real-time operating system. Real-time operating systems often rely on vector table to manage interrupts and schedule tasks. The vector table provides a centralized mechanisms for real-time operating systems to handle interrupt-driven tasks and prioritize critical operations. Integration of the vector table with real-time operating system can enhance the system's responsiveness and efficiency. Debugging and troubleshooting with vector table. The vector table play a crucial role in debugging and troubleshooting interrupt-related issues in microcontroller applications. By examining the vector table content, developers can identify the mapping between interrupt sources and their corresponding handlers. Debugging tools and software often provides features to visualize and analyze the vector table for diagnosing problems. Next, vector table optimization. Efficient utilization of vector table can contribute to improved performance and responsiveness of the microcontroller system. Optimizing the vector table involves organizing and prioritizing interrupt handlers based on the application requirements. Minimizing the overhead of interrupt handling routines can help streamline the execution flow and reduce latency. Best practices of vector table design. When designing the vector table, it is essential to allocate sufficient space for accommodating all necessary interrupt vectors. Organize the vector table in a structured manner to facilitate easy maintenance and debugging. Documenting the vector table layout and contents can aid in understanding the interrupt handling mechanisms. Steady case ARM Cortex M vertex table. The ARM Cortex M microcontroller features a standardized vector table format known as the Nested Vectored Interrupt Controller (NVIC). The NVIC provides a scalable and efficient mechanisms for handling interrupts and exceptions in ARM-based microcontrollers. Developers can configure the NVIC through registers to customize, interrupt, prioritize, and enable or disable specific interrupts. Vector table security considerations. Protecting the integrity of the vector table is critical for ensuring the security of the microcontroller system. Unauthorized access or modification to the vector table can lead to vulnerabilities and potential exploits. Implementing security measures such as memory protection and access control can safeguard the vector table from malicious attack. Vector table and multi-core processors. In multi-core microcontrollers, each core may have its own vector table to manage interrupts independently. Coordination between vector tables in multi-core systems is essential to ensure proper handling of interrupts and synchronization between cores. Inter-core communication mechanism may be utilized to facilitate interaction between vector tables and coordinate interrupt handling. Vector table backup and redundancy. In mission-critical applications, a redundant vector table can be employed to enhance system reliability and fault tolerance. Backup vector tables can be activated in case of primary vector table corruption or failure. Implementing redundancy strategies for the vector table can help mitigate and the impact of potential failures on the microcontroller systems. Vector table in automotive applications. The vector table is extensively used in automotive microcontrollers to manage various vehicle functions and safety critical systems. Automotive grade microcontrollers employ robust vector table designed to handle interrupts from sensor actuators and communication interfaces. Compliance with automotive standards such as ISO 26262 requires through validation and testing the vector table implementation. Next, future trends in vector table technology. Advancement in microcontroller architecture and design are driving innovation in vector table technology. Future vector table implementations may incorporate advanced features such as dynamic vector allocation and virtual vector tables. Integration of machine learning algorithms and predictive analysis could optimize interrupt handling and enhance system performance. Conclusion. The vector table is a fundamental component of microcontroller system that facilitates efficient handling of interrupts and exceptions. Proper design and management of vector table are essential for ensuring the reliability, security, and performance of embedded applications. Continual advancement in vector table technology are shaping the future of microcontroller development and enabling new possibilities in embedded systems.